In this video, I'm going to show you how to compute a confidence interval for a population mean when the standard deviation is unknown, and this is the typical scenario that we will be in. This procedure has two requirements. The first requirement is that you have a good, simple, random sample. So that means a sample collected through very good sampling methods. And then your second requirement is that your sample size is large, so at least 30 items, or you know that the population your sample is coming from is approximately normal. The steps of the procedure are as follows. Once you have verified that you meet the requirements, you will compute your sample mean and your sample standard deviation if they're not given. Then you will use the student's t distribution, which sometimes I'll just say t distribution, to find the critical values. So this procedure uses the student's t distribution, not the standard normal curve. Once you find the critical values, you'll find the standard error, and then you'll multiply it by the critical value to find the margin of error. Then given the margin of error, we will add or subtract it to the point estimate, which is the sample mean, and that will give us our confidence interval. So let's look at this example and work on it together. The General Social Survey asked 1,972 adults how many years of education they had. The sample mean was 13 and 37/100 years with a standard deviation of 3 and 13/100 years. We're going to construct a 98% confidence interval for the mean number of years of education, and then we're going to interpret the results and answer a question. So first thing that I'm going to do is I'm going to write down the information that we get from this question. We are told the sample size, which is N, and that's 1,972. We are told the sample mean, X bar, which is 13 and 37/100 years of education. And then we're told the sample standard deviation, which is lowercase s. All right, now let's talk about these assumptions. In this question, I have a survey of 1,972 adults, which is absolutely large enough to satisfy requirement 2. And then as far as requirement 1, do we have a simple random sample? We are told that this survey was done by a group, the General Social Survey. We will make the assumption that it is a simple random sample. Let me say it this way, that this survey was done in a way that everyone had a chance of being selected. Now, whether that's true or not, we don't know the details of how the survey was collected. For the most part, given a homework question like this or, a simple test question, you'll assume that you're meeting that requirement. However, if you are told more details about the sampling method, then you're going to want to really analyze whether it's a good simple random sample. So for the sake of the exercise, we'll go ahead and say that this survey satisfies this. Now, we're told the confidence level is 98%, and that means that alpha is equal to 0.02. So now we're going to find the critical values, and we're going to find those using technology. For technology, I'm going to use Desmos, and I'm going to get the t distribution up. We need the degrees of freedom. The degrees of freedom are the sample size minus 1. So N minus 1 is 1,971. We want the outer boundary for an area of 0.02. This is what the visual looks like. And then these are the critical values. Round them to what's appropriate. We will round to the 3 decimal places. Critical t value equals 3 to 8. On the picture, they are the boundaries of the error region that you see shaded. Now that I have the critical value, I'm going to find the standard error and the margin of error. So for the standard error, we're going to take S and divide by the square root of n. And then for the margin of error, we're going to take the t-value and multiply that by the standard error. I'm going to use a calculator for both of these. S for us, I'm scrolling back up, is 3.13 divided by the square root of 1,972. And then the margin of error, which I will call M, you don't have to name it, but I'm going to use that later, is 2.328 times the standard error. We do not want any rounding error, so we will compute it in this way. So then given those numbers are ready to create the confidence interval can be written in 3 ways. We're going to take the point estimate and we're going to add or subtract the margin of error. And so that's where I'm going to use that, what I called it. The point estimate for us is the sample mean, so that's 13.37. Adding M is going to give me my upper bound. Subtracting M is going to get me my lower bound. And then I can write these in any way that I need. All right, so for example, let's see. Sample was rounded to 2 decimal places, so we're going to round in kind. So one way we can write the answer is 13.37 plus or minus 0.16 years of education. The other way we can write it is we can write it in interval notation. So the lower bound is 13.21, and then the upper bound is 13.53. Or I can write it in inequality notation. Lower bounds, 13.21 years, is less than the population mean, which is less than the 13.53 years. So these are the 3 ways that we can write our confidence interval. Now, let's interpret the results and look at the second part of the question. It says data collected in an earlier study suggests that the mean 10 years ago was 13.26 years of education. A sociologist believes the mean is now the same. Does the confidence interval contradict this belief? Explain. So let's look at our interval. 13.26 is inside our interval. Right, here's a visual for those of you who might be a little more visual. These values represent a number line. Here's the 13.21, here's the 13.53, and what we're saying is we're shading all values inside this interval. Now, we know that the population mean, or we are 98% certain that the population mean is somewhere in here. And so if she says that she has a 13.26, then that would be a value within our confidence interval. And so the request or the belief that the mean education level, the mean number of years of education is the same is reasonable to conclude because the 10 years ago mean is inside of our confidence interval. I hope this helps. Let me know if you have any questions and you can ask them in the chat.